So in the last lesson, I discussed how to write the formula and the name for ionic compounds of known charge. Well, what exactly does that mean, known charge? What would be unknown charge or variable charge? Well, here's the situation. Remember, if we look at our periodic table, I know group 1 always has a +1 charge, group 2 is +2, and group 3 is +3. There are only 2 other elements whose charges I always know, and those include zinc and silver. Okay? Just because of how their electron configurations work out as far as stability is concerned, silver will always have a 1+ charge, and zinc will always have a 2+ charge. Okay? If I don't have a group 1, group 2, group 3, or silver or zinc, then I have that I'm dealing with a metal of variable charge. Notice I'm really talking about my transition metals. Okay? So why does that matter? Well, if I were to write out the name for a compound, let's say, for example, iron. If I were to write out iron chloride, if I were to write that out and I asked you, hey, write out the formula for that compound, you wouldn't be able to do that, and I wouldn't be able to do that, because when I look at iron, seeing that it's a transition metal, I have no rules for knowing what the charge of that metal is. And remember, the reason why it's a little bit quirky is because you've got this S sublevel here, and then all of these atoms have elements that are occupying the D sublevel. So they're not just going to lose 2 electrons or 1 electron. They could lose 3 or they could lose 4. And so knowing the charge is complicated. So here's how I actually show the charge with my audience. What I'm going to do is I'm going to write the name of the metal, just like what I did before. I'm going to write the name of the nonmetal, just like I did before. And remember, the nonmetal is going to have an IDE ending. The only new thing, and this is only for metals whose charge I don't know, these transition metals here, except for silver and zinc, I'm going to put the charge of the metal as a Roman numeral. And so that's how I'm going to share what the charge of the metal is, so that my audience will know what ion I'm talking about. So quick review of Roman numerals. I is 1. Okay. II is 2. III is 3. IV is 4, because you take away from the 5. V is just 5. 6 is VI, and that's the highest you'll ever go with this. Okay, so in order to solve these problems, if you're having to name the compound, the first thing you need to do is say, all right, do I know the charge of my metal? If the answer is yes, do not include a Roman numeral. If the answer is no, then you need to include a Roman numeral. So let's look at this. Iron, FeO. So I'm going to first write out the name iron oxide, because I know how to do that. And now I need to check, all right, do I know the charge of this metal? And remember, I do not, so I've got to figure it out. So here's where you're going to have to put on your thinking cap. All right, the charge of oxygen is 2-, and I only have 1 oxygen. So what does the charge of iron have to be in order to cancel out the charge of oxygen? Well, the charge of iron has to be 2+. So when I'm writing the name for this compound, then it's going to be iron 2 oxide in order for me to express the charge of iron. All right? All right, so for chromium 3 hydroxide, by giving you the name of this compound, I've now told you the charge of chromium, because otherwise I wouldn't know it, because it is a transition metal. So chromium here, I tell you in the name, its charge is 3+. And then I give you hydroxide. Remember, the formula for hydroxide is OH, and its charge is 1-. You can look that up in your table. So I'm going to cross my charges. Okay. And so the formula for this is going to be Cr, in parentheses, OH, 3, because remember, if I have more than 1 polyatomic ion, I've got to put it in parentheses. Okay, let's look at the next one, PbSO42. So this is going to be, I'm going to first write out the name, lead sulfate. And let's look to see if I need to include a Roman numeral for the charge, or if, by looking at the periodic table, I know the charge already. Well, lead is right here, so I do not know its charge, so I've got to figure out what that would be. So let's problem solve this. All right, sulfate, if you look at your chart, has a 2- charge. How many sulfates do I have? Well, I have 2 of them. So sulfate overall contributes a 4- charge. So what would the charge of lead have to be in order to cancel out that 4- charge? Well, the charge of lead would have to be 4, right? It'd have to be 4+, because 4+ and 4- would give you 0. So I'm going to put lead 4 sulfate. Okay, and that's the name. Let's look at the last one. Tin 4 chlorite. Okay, so tin, I'm telling you in the name, it has a 4+ charge. Okay, chlorite, notice it's an ITE ending, and so that's going to be one of my polyatomic ions. So chlorite is ClO2, and it has a -1 charge. So when I go to cross my charges, this is going to be SN, ClO2, and then I need to put the 4, but remember I don't want to have 24 oxygens, I want to have 4 chlorites. So I'm going to put the chlorite in parentheses. All right, so the first question you should be asking yourself when you are having to write the name, first write out the name, that's fine, and then go back and say, okay, do I know the charge of my metal? If it's not a group 1, group 2, or group 3 metal, or zinc or silver, then I need to include the charge as a Roman numeral. In order to write the charge, I've got to figure it out. So example 1 was pretty easy to figure out the charge of iron. Example 3 was a little bit more tricky, and so you're going to get more practice with that.